The Segura Lab is tasked with creating regenerative hydrogels. Each member brings new techniques and chemistries to heighten the field of biomaterials. But before they can graduate, they need to make their ideas come to life. Let's see what everyone is cooking up. On this week's Master Researcher Kitchen Chemistry Edition.
This year we're more hands-on.
Each research project has been carefully designed to see who is a brilliant scientist.
I knew this competition was going to be fierce right when I came in. It's so hard to get these hydrogels to be something novel that we can make. And so yeah, as a second year student, I've had some experience now in Segura Lab working on these hydrogels, and I'm confident that we can create a novel system that will allow for both injectable hydrogel as well as one that promotes good tissue regeneration. The advantage of this system is that we can make these high throughput thanks to some emulsifier or microfluidic production. And akin to past methods, we can create these spherical-like microgels that, when combined and melded together, create this porous scaffold that allows for easy cell infiltration. Of course, my take on this is trying to combine these hydrogels with some type of therapeutic gene delivery. And what can be seen is just so much work and effort having to go into just making these vectors alone, and having them combined into our hydrogels can lead to a lot of issues from the process of just trying to make these gels, and the microgels not coming out like spheres at all, but these clumps. And in the end, through mistakes, I found that these clumps can still work well for gene delivery, as well as having cells grow into the scaffold. So some mistakes can lead to benefits in the long run.
The thing with hydrogels is all in the seasoning. Too much norbornene or not enough crosslinker, and the whole gel will just fall apart.
You'll first be using about 100 mg of hyaluronic acid, and you can weigh that out using your scale. So dissolving is definitely the hardest part of this whole recipe. It's basically a workout, I know. Okay, so once that looks nice and dissolved, the next step will be to add your very best. The point of this step is to activate that carboxylic acid group on your hyaluronic acid backbone so that then we can add that norbornene. This next step is going to be to add your 5-norbornene to methylamine. So then what we're going to do is stir this overnight at room temperature in the dark. So make sure to keep it out of light. So the next thing that we need to do after stirring that overnight in the dark is to then precipitate our 18-norbornene here in diethyl ether. If you'll follow me to the final step is to put this in the centrifuge. Okay, so let's pull this out and see how it turned out. Gosh, amazing!
Here we can see Sophia taking part in full head-to-toe science, where not a single thing goes to waste, including the grain.
This is how much jelly you make.
After she's sliced them 30 microns thin, she's going to have to come up with a good combination of antibodies that really just brings out the data.
Fluorination is our hyaluronic acid hydrogel that we definitely buffed up. We added our adrenoparticles, our positive VEGF on our adrenoparticles, and then we processed the whole thing with an MMD degradable process. After taking it off the heat, it should start reacting really quickly. It's going to be a very, very viscous solution. For this application, I'm going to be using our stroke model, our photothermal stroke, and I'll be injecting our HA hydrogel right into the stroke implant. And so I'm going to load up our syringe with our HA hydrogel solution. We'll use a mouse model for our stroke with photothermal stroke. And so there we have our mice that we've already stroked. And so at day 5 post-stroke, we're going to inject our biomaterial into the brain. And here you go, guys. This is our Fluorina HA hydrogel for stroke application.
Competition out there is getting fierce, and so I really need to use some spices to make my hydrogel dish really stand out. I want to heal chronically inflamed wounds, and that's why I turned to my special secret ingredient, the spice inter-alpha inhibitor. It helps to suppress inflammation by addressing the innate immune system, and it does this by polarizing macrophages into more pro-regenerative phenotypes and maintaining neutrophils in more quiescent state. What this does is it mutes some of those really overbearing flavors of inflammation and allows more delicate flavors like proper ECM production and vascularization to really develop. Yeah, I know not many people are using interalpha inhibitor as a spice, but sometimes you gotta be creative, you gotta take risks when you're cooking with hydrogels, man. After seeing all of the hydrogel dishes, it is now up to each member's committee to determine the merits of their creations.
It's the biggest, the boldest, but yeah, the most competitive season ever.
Tune in next episode to see who will have a successful research project and who will have to leave the Segura kitchen.